Hello, welcome to another video. Now it's possible that before now, any answer you get when you solve an equation or an inequality will always work. But you have to start thinking of the domain of the function you're working on. You see, because if you don't take that into cognizance, what happens is you're going to get an answer, but when you try to plug it in, it will not work because that answer you got is not in the domain of the function you're working with. And that's why it's a dangerous thing to cross multiply. Don't cross multiply whenever you're doing inequalities. Let me show you. Well, the first thing you want to do is let's introduce natural log to get rid of the e. Okay, so if we say natural log of e to the 3 over x minus 3 is greater than 1. Well, that 1, we have to introduce natural log on this side too. So that's natural log of 1. Well, we know that the natural log of 1 is going to be 0. But I want to make a comment here. Because you're taking a natural log, remember that the base of a natural log is e. Okay, that's why these two will cancel out at this point, and then you have this one. But let's say the base was not e. Let's say the base was a fraction. Okay? Any value that is less than 1, what you're going to have is that the sign will change. Okay? You can watch other videos to see why that happens. This sign has to be reversed and this will become a less than. But because the base of the natural log is a value, which is e, is a value that is greater than 1, the sign is going to remain. So let's just move on. So at this point, we can have 3 over x minus 3, and that would be greater than the natural log of 1 is 0. Okay, now what I see many students do is that they try to solve these as if it's just an equation. Okay, well, let me show you what most people do and what they shouldn't do. What they do, so don't do it. Okay, so don't do this. What I'm about to do, don't do it. So people do 3 over x minus 3 is greater than 0. They add 3 to both sides. They end up with 3 over x is greater than 3 over 1. Then they cross multiply. They say 3 is greater than 3x. And that gives them 1 is greater than x, or x is less than 1. So what this tells us is all values of x from here, from less than 1 to from negative infinity to just before 1 satisfies this inequality. So which means negative infinity all the way to like this. So this range, this interval satisfies this expression. But that's not true because this includes 0. Well, 0 is not in the domain because x cannot be 0. It will make this undefined. Okay, so 0 is not in the domain just because of that. So it's always good for you to check out what the domain of the function actually is. So the domain of this function is all values of x, because that's what happens for e to any function. However, that value cannot give you an undefined expression. Therefore, x equals 0 is not a part of the answer. But this tells you that x equals 0 can be a part of the answer. 0 is one of the options because you're dealing with x being values less than 1. So don't do this style of solving inequalities. Firstly, you have to recognize the domain, okay? And secondly, don't do cross multiplication because you're not sure if x is going to be positive or negative. And if it's negative, eventually this sign might need to change. If it's positive, this sign will remain the same. That uncertainty also does not allow you to do cross multiplication. And also cross multiplication gives you answers like this that do not recognize whether it actually validates this. Because let's say x is 4, or negative 4 rather. If you plug in negative 4 here, this inequality will not be true. Let me show you why. Plug in negative 4 here, okay? You're going to have 3 over negative 4, which is a negative number okay, minus this, that's negative. But when you take this value, it's not going to be greater than 1. It's actually going to be less than 1. So this is not a valid answer. Don't do it, don't cross multiply. And that's true also for this side. So let's solve it the correct way. So the correct way of solving this is simply getting a rational expression on this side, because there are two terms on the left. Just make it 1, okay? So take the least common multiple. This is going to be rewritten as 3 minus 3x over x is greater than 0. So we're looking for all values of x that will make this side greater than 0. And anything greater than 0 is what we call positive, okay? So what expressions will make this positive? Well, it's difficult for you to deal with the numerator and the denominator at the same time, okay? So what you want to do is look for the critical values of the top that will make it positive. Look for the values for the bottom that will make it positive. And then you now take a ratio of the two and see when both of them will give you, when combined, will give you positives. So let's take the critical values, and this is what I mean. Because you see, the critical value happens at, okay, how do you know when a number, okay, how do you know when something is positive? Well, it's when it is greater than 0. How do you know when it's negative? It's when it's less than 0. So let us take 0 as our reference point and equate this expression to 0, find the number, and then now judge when it's negative or positive. That's what we call critical values. Let's do that. So critical values, okay, we have for the numerator will be 3 minus 3x equals 0, and then you have x will be equal to 1. For the denominator, you have x equals 0. Well, those are the two critical values that you need. Okay, so now let us test. Why are we testing? We want to see when this expression is going to be greater than 0. So you write the two critical values, which are 0 and 1. And you're going to test different regions, different values here to see what works. So let's test this region, and this region. Pick a number here that is less than 0. Well, -1 is a good option. If you plug in -1 into this expression, you're going to have 3 plus 3, which is positive. That's 6 divided by negative. Oh, so that's positive over negative, which makes it negative. Okay? Remember, that's not true because x is supposed to be positive, greater than 0. So this region does not satisfy the inequality. Now let's go to the middle. Pick a number between 0 and 1. See, a very good number to pick here would be 1/3, because you can easily multiply 3 by it. So if we pick 1/3, okay, let's test 1/3. 1/3. Okay, 1/3, this is going to be 3 minus 1, which is 2. That's positive, over 1/3. So that's positive over positive, which makes this region positive. That's good. Let's test the third region. Pick a number greater than 1. Well, a good number will be 2. So if you plug in 2 here, what you're going to get will be 3 minus 6. That's negative over positive. Everything is negative. So this region is also negative and not accepted. So the only solution, our solution lies between 0 and 1. Okay, so you say x is such that 0 is less than x and x is less than 1. Well, we know this is correct because it is within the domain. Remember, we said 0 cannot be part of our answer, so that's the number excluded, and our answer also excludes 0. Okay, so any number from 0 to 1, if you plug it in here, will satisfy this inequality. This is how to solve inequalities, especially if they have rational expressions. Let's go to number 2. So for any inequality or even equations that contain natural log, you want to be careful. You want to be careful in the sense that the domain of the argument, okay, of natural log has to be greater than 0. You can't have a negative expression and take the natural log of it. You can have 0 and take the natural log of it. So there are two conditions you want to look out for. This cannot be equal to 0, which means that 2x minus 3 cannot be equal to 0. That's one condition, okay? Secondly, you cannot have an undefined expression, which means the base cannot be equal to 0. 7x plus 1 cannot be equal to 0. And the third condition for this is the combined expression cannot be negative because there's no natural log of a negative number. So the third condition is 2x minus 3 over 7x plus 1 cannot be negative, which means it must be greater than 0. So when you want to look for the domain of any function, especially a rational function, just look for the critical values. So let's quickly take the critical values of this. Okay, remember what we're doing is we're not solving the inequality yet. We're just looking for what the domain is so we know whether our answer at the end is right or wrong. So you want to say that 2x minus 3 equals 0. That means x equals 3 over 2. And you want to say that 7x plus 1 equals 0, which means x is negative 1 over 7. Okay, let's quickly test. Okay, the two values we have are negative 1 over 7 and 3 halves. Okay, pick a number less than negative 1 over 7. Negative 1 will be a good option. So if we pick negative 1 here is going to give you a negative on top and a negative under. So negative over negative gives you positive. So this region is a good region to pick your answer from, okay, because it's positive. Let's test between this and this. Let's use 0. If I plug in 0 here, you're going to have negative on top, positive under. Negative over positive gives you a negative. So this region cannot contain your answer. This is all negative, so no. Let's test this region. This region is going to be a number greater than 1 1/2 will be 2. If you use 2 here, you're going to get 4 minus 1. That's positive over positive. So this is another good region that can contain your answer. So by the time we're done solving this problem, your answer has to be either in this region or in this region or in both. But it cannot be in this region. And it also cannot contain negative 1 over 7. It cannot contain 3.5 because those two will make this not meaningful. Our first step is to, well, get rid of the natural log, which what we want to do is we just want to express it to the e. Okay, that's what I'm going to do. And that gets rid of this, and then we have 2x minus 3 over 7x plus 1 is greater than 5. Okay, like I said, please do not cross multiply. Okay, what you want to do is take 5 away from both sides, and that moves the 5 down here. You have 2x minus 3 over 7x plus 1 minus 5 is greater than 0. So now remember, at the end we'll be testing whether the left hand side is positive, greater than 0. So what we're going to do now is, well, you can make it into just one. Take the LCM of both sides. You're gonna, of the two terms, you have 2x minus 3 minus 5 into 7x plus 1 over 7x plus 1 greater than 0. If you open this up, you're going to have 2x minus 3 minus 35x minus 5 over 7x plus 1 greater than 0. Let's gather this together. This is negative 8, or let's say negative 33x minus 8 over 7x plus 1 is greater than 0. Okay, remember, we just want this to be greater than 0. So all we're looking for are those critical values, and then we'll do our test like we did for the other one, like we did for this. So for the numerator, get the critical values. For the denominator, also do the same thing. So let's do that. So we're going to say critical value. This will help you. Just write numerator. The numerator is negative 33x minus 8. So negative 33x minus 8 is equal to 0, which means x is going to be negative 8 over 33. Okay, for the denominator, it's going to be 7x plus 1. 7x plus 1 equals 0, and that makes x equal negative 1 over 7. So which of these, let's do our test. Okay, so which of these goes to the left, which one is on the right? Well, the easy way to do this is to, since this is 1 and this is 8, why don't you, in your mind, multiply this by 8? So you're going to have negative 8 also, but you're going to be multiplying this to by 8. So you have two fractions, negative 8 over 33 and negative 8 over 56. Which of those is a bigger number? Well, this has to be a bigger number in terms of the magnitude, but now it's more negative because it's the bigger number. So it's the bigger, no, it's the more negative number. Okay, I know it's the smaller number, but it's the more negative, so it goes farther to the left. So this has to be negative 8 over 33, and this is negative 1 over 7. So those are the two numbers we're going to be checking out. So let's start the test. Let's pick a number here. Negative 1 is a good option. So plug in negative 1 into the rational expression. If you put negative 1 here, this is going to end up with 33 minus 8. Whoa, that's gonna be positive, but this is going to be negative. So this is positive over negative, which makes this region negative. Okay, we don't want a negative region because what we're looking for is something greater than 0. Okay, so we're looking for positives. Let's test. Okay, this is tough a bit. Why don't we go to the easy one? Give me a number that is greater than negative 1 over 7. Well, 0 is a good one, but we can't. Can we use 0? Is 0 part of the domain? It doesn't look like that. We have to pick a number that's within the domain. Let's pick 2. Okay, so we're gonna pick 2. You see why I didn't pick 3? I didn't pick 0 because it looks like 0 is not in the domain. So that's why it's good for you to recognize the domain before you do your test. So I'm gonna pick 2 because I know 2 is gonna be in the domain, and then let's test for 2. Put 2 here. There's gonna be a huge, that's gonna be negative 66. So the top is gonna be negative, positive, negative over positive, and this region is negative. So this is another negative value, so I'm gonna say no. Now let's test between these two. Well, this is 8 over 33, this is 1. So I can try negative 1 over 6. Just slightly away from here, that makes sense. Negative 1 over 6 or negative 1 over 5. Negative 1 over 6, if I put it here, this is going to give me approximately positive 5 point something. Okay, positive 5 point something minus 8 is going to be a negative result on top. If I put that number here too, this is going to be negative 1 point something plus 1, that's negative. So it's negative over negative, which makes this region positive. Now I am very confident that I am correct because I recognized the domain of the inequality in the first place, the domain of this side, and I've used it also in my testing, and whatever answer I have now is absolutely right. So it means my x is such that x is strictly between negative 8 over 33 and negative 1 over 7. If you learned something in this video, make sure you give it a thumbs up, give it a share, give it a good comment, give it a subscription. And make sure you hit the notification bell so you know when the next video is up. I'll see you in the next video. Until then, don't stop learning. Those who stop learning have stopped living.